We've added and subtracted rational expressions. We've multiplied rational expressions. Now we're going to look at division of polynomials. This is going to help us a lot with further activity with rational expressions. So the simple part, dividing a polynomial by a monomial, then dividing two polynomials. That is, the divisor is a polynomial other than a monomial. We'll see how that is. That's a little more difficult. We'll start with some things we're familiar with. Well, this looks altogether too familiar, doesn't it? We want a common denominator for our numerator and a common denominator for this, our denominator. Ooh, gets confusing talking about it, doesn't it? What are we looking at here? This is a complex rational expression. That is, we have a rational expression in the numerator and a rational expression in the denominator. So the way we've been handling these is to get the numerator into a single fraction, the denominator into a single fraction, and then set it up as a division of fractions. So common denominator here, we're going to want a. So a over a plus 1 over a is the same as a plus 1 over a. That's that common denominator. This we will convert to a over a, and we'll have a plus 2 as our binomial all over a. So that's a plus 1 over a divided by a plus 2 over a. We're going to stay a plus 1 over a, change to multiplication, and flip. Take the reciprocal of the divisor, a plus 2, and that simplifies to a plus 1 over a plus 2. How about this one? We don't have to do too much to that numerator, do we? But down here, we're going to have to get this fixed up. We'll have 2x over 2x for our fancy one. That'll be 2x plus 1, both of them over 2x, which is 1 divided by 2x plus 1 over 2x. We will stay, change, flip. And we get 2x over 2x plus 1. And I know there will be at least one of you out there who is tempted when they see this and they see this to think, well, those look the same, why can't I cancel them? No! You cannot do that because this is not a factor, this is a term. How do I know it's a term? Because it's got this plus 1 with it. Never cancel terms. Okay, never, it's a pretty strong word, and I mean it. Never cancel terms. Okay, we can get started. Before we start dividing polynomials, let's go back to what we learned in elementary school. It's been a while, and especially with your calculators, you probably haven't done much with long division. We're going to review those rules of long division right here by doing this problem. Now, 235. How many times would it go into 6? Well, it wouldn't go into 6. It wouldn't go into 67. Oh, but it would go into, it has to be a larger number, right? It would go into 676. Well, how many times do you think it would go? 3? Probably not, because I'd get the 600 and then I'd get 3 times 35. So I'm going to try 2. I'm going to have a remainder, aren't I? So it's 2 times 5 gives me 10. Carry 1. 2 times 3 is 6. And we carry that 1 for 7. We have nothing to carry now. 2 times 2, 4. I'm going to subtract the product. I'll have 6, 0, 2. What I check for now is this less than my divisor? If it weren't, it would mean I should have gone with 3. It is less than my divisor. 235 will not go into 206. I'm going to bring down the next number and think about how many times would this go into 2000 and something. Well, I think it'll go at least 8 times. What do you think? You think I should go 9? I'm going to be very conservative. I'm going to go 8. If it turns out to be too little, I'll go back and do 9. So that'll give me 40, carrying 4. 8 times 3 is 24, and that 4 that I carried makes it 28. So I'm carrying 2. 8 times 2 is 16, plus the 2 I carried is 18. Now I'm going to subtract that product. 8, 8. Did I do that right? 188. So the answer to this one is 28 with a remainder of 188, which I can express as 188 over my divisor. Okay? Just a reminder of how we do long division. We're going to use the same rules with polynomials. Here I have a cubic trinomial, which I want to divide by a monomial. So I look at 2x, and I think, how many times will that go into 6x cubed? In other words, what can I multiply this by to get 6x cubed? Well, 3, right? And x squared. This is my x squared column right here. That's where I'm going to put my multiplier. So I'm going to say 3x squared. 3x squared times 2x gives me 6x cubed. Now I subtract it and I get 0, which is what I wanted to get. I bring down the plus 2x squared and I consider what I could multiply 2x by in order to get 2x squared. That's right, 1x. X times 2x, 2x squared, I'm going to subtract that, and I get 0. And then I bring down the next one, which is a plus 8x. I'm going to have to extend this, aren't I? And I had third power, second power, first power, and then I want the 0 power. So 0 times x to the 0. What is x to the 0 power? What is that equal to? 1. That's right. So we've got 0 times 1 here. All right, what do I multiply by now? 4. All right, plus 4. And I get 8x, which I subtract. I get 0 plus 0, so I have no remainder. When I have no remainder, that's something I like, because that means this factored into this evenly. So if I wanted to write this as factors, I'd say 2x times 3x squared plus x plus 4 equals 6x cubed plus 2x squared plus 8x. Now you're probably looking at this and thinking, well, I could have done that without going through this long division. Yes, you could have. But I want to show you how you do it with long division, because shortly we'll come across things that you won't be able to factor by sight. Sometimes there will be a remainder. So let's see what happens in that case. What would we multiply 4x by in order to get 8x squared? 2x. So we're going to put it in the x to the first power column. 2x. We multiply it, we get 8x squared. We subtract that, 0. We bring down the next thing, which is plus 4x. How many times will that go in? 1, you tell me? That's right. And then we have 4x, which we subtract. We get 0. But we're not done. We have this other term, plus 12. And 4x cannot possibly go in evenly with 12, which has no x. So we end up with 2x plus 1 with a remainder of 12, or we could express it as 12 over our divisor of 4x. We probably wouldn't leave it like that, would we? We would simplify it. 2x plus 1 plus 3 over x. That would be our answer. If you divide a 3-term polynomial by a monomial, how many terms will the answer have? I don't think there's any other way to do it. If it's by a monomial, you're always going to have 3. Let's look back here. Do we have that situation? Well, this has 3 terms. This one has 3 terms because there was no remainder. Actually, there could have been a remainder here, which would have given us one more term. I guess we could say at least 3. If you divide a polynomial by a monomial, any polynomial by a monomial, will the answer always be a polynomial? This wasn't. This remainder changes it. This is no longer a polynomial. It doesn't fit the definition, which was that x always has an integer. It cannot have a negative. This, if we wrote it out, oops, 2x plus 1 plus 3. Oh, that's supposed to be a plus. Sorry. Plus 3x to the negative 1. This doesn't fit because we have a negative exponent. So, no. Try another one. Now this gets more interesting because this time we are dividing by a binomial. We're going to focus in on the first of it though and say, okay, what could we multiply x by that would give us 2x squared? 2x. And we place it in the column which has x to the first power. Then we do our multiplication. 2x times x gives us 2x squared. 2x times a positive 1 gives us a positive 2x. What is our next step? To subtract. When we subtract this, we get a 0 here, and that's right, we get x here. Now we bring down our next term. What are we going to multiply x by in order to get x? We use the multiplicative identity of 1. When you multiply anything by 1, it stays the same. X plus 1. And now we subtract that. We get an answer of 4. So we have 2x plus 1 plus 4 over x plus 1. I suppose another way you could say it is you have 2x plus 1 with a remainder of 4. Ooh, let's have a little more fun. X plus 1 divided into all of this. We're going to focus in, remember, on just the first term in the divisor and the first term here. So that would be x to the third. We're going to put it here. X to the third times x will give us x to the fourth. That's what we wanted. Plus x to the third. Now we're going to subtract that, and we get 0. We bring down our next term, x squared. That's not going to be enough. Because we have a binomial, we're going to bring down both of the next ones. We had 0 here, so now what are we going to multiply by? An x. So that goes into this column right here. X. X times x will give us the x squared that we want, plus x. And we subtract that product, giving us 0 and a positive x. Now this time we only have to bring down one term because we already had the x here. How many times do we need to? This one's going to work out very nicely, isn't it? 1 times x, 1 times 1, and we subtract that. We get the very sweet result of a remainder of 0. So our answer here with a remainder of 0, this means that it factored evenly. And we could write this, if we were talking about factoring, as this binomial and this trinomial are the factors of this expression here. This looks like something you might see again, doesn't it? Maybe, maybe not. Okay. Now, what do you do if a power is missing? We haven't run into that previously. In all of these, well, this one actually we did run into it, didn't we? We had x to the third, x to the second, x to the first, and we did not have x to the 0, so we did put that one in. Here we had x to the second, x to the first, x to the 0, x to the second, x to the first, x to the 0, fourth, third, second, first, and 0. But in this one, we have one in the center that's missing. We've got x to the third, x to the first, x to the 0. So in that case, we put in a placeholder. Let's go through one of these. That gave us a place for us to put our x squared, which we need here. X to the third plus x squared. We're going to subtract that. And that will be a 0 here and a negative x squared. If you're subtracting 1x squared from 0x squared, you're going to have a negative 1. Now we're going to bring down the next term, so we'll have a binomial here. X plus 1. Well, what are we going to use now? We're finally getting into a negative. That's right. Negative x. We'll have negative x squared. And negative x times 1, negative x. Now watch out for this when you're subtracting and you've got negatives, right? This will 0 because when you distribute this, if you were thinking about this as an additive inverse, this would become a plus x squared and a plus x. So you end up actually with 2x. We bring down the next term, plus 3. What are we going to multiply by? That's right. 2x plus 2, which we subtract. And when we do, this zeros, this was a negative 2 and a positive 3, give us a 1. So our answer is x squared minus x plus 2 with a remainder of positive 1, or we could write it as an additional term, 1 divided by our divisor. Let's keep going with this. 2x minus 3. 2x. Now, yeah, we focus here and here. What are we going to multiply this by in order to get 2x to the 4th? X to the 3rd. And when we multiply that out, we get 2x to the 4th minus 3x to the 3rd. Is that correct? Let's try subtracting it. We're always looking at this stage to see this become 0. If it didn't, we have to go back and redo it. It does become 0. When I subtract a negative, it becomes a positive. So positive 3x squared and a negative 11x, positive 3x cubed and a negative 11x cubed will be a negative 8x cubed. We bring down the next term. And we look for what could we multiply 2x to get a negative 8x cubed. Well, that would be a negative 4 to get the negative 8, and x squared to get the x cubed. When I multiply that, I get a negative 8x cubed, which is what I wanted, and a positive 12x squared. Now I subtract that product, which gives me a 0 as I wished. A negative 12x squared from a positive 14x squared is a positive 2x squared. Bring down the next one. This time I will multiply simply by a positive x. 2x squared minus 3x. Subtract it. This will 0, and then I have a positive 3x and a negative 5x for a negative 2x. I bring down this last term, plus 6. And I have, let's see, a negative 1 will do it, won't it? Negative 1 times 2x will give me a negative 2x. See, I'm always trying to match this, because I know if I do, when I subtract it, it will 0 out. And this will be a positive 3. Now I subtract it to get my good result of 0 here. And I'm subtracting a 3, a positive 3, from a positive 6. That will give me positive 3. So I end up with a remainder of 3, or I could write it like this, plus 3 over the divisor for my answer. Whoops. Try another one. We're going to go through quite a few of these. Let me see how many I've got left. Oh, 2 more problems to do. I think it's worth it. If you've already got the hang of it, take a look at this. Actually, any case, you can work these independently. Just turn the volume off and go ahead and do it on your own. Pause this if you need to, if I start to get ahead of where you are. So, I need x to the 4th, don't I? Positive x to the 4th will give me 3x to the 5th when I multiply it by 3x, and I'll have a negative x to the 4th. This gives an interesting result, doesn't it? Like an earlier problem, zeros everything. That means that I'm going to have to bring both of these down this time. So I've got 0, x to the 3rd. Notice we put a placeholder in because we had 5, 4, no 3, 2, 1, 0. I don't have to worry about getting rid of that. It's already gotten rid of, isn't it? So I can just go on to this one, and I guess I better bring down this minus 7x. 3x into 12x, that'll be x squared, 12x squared. 4x, so I'll put it over here. Wow, we skipped over quite a bit there. 12x squared minus 4x. Now I'm going to subtract that. And of course, this was never anything anyway. I get a 0 here, and when I subtract a negative, that's the same as adding. 4 to a negative 7, I get a negative 3x plus 1. So, oh, I should put a sign on here. That was a positive 4, wasn't it? Yeah. What do I need? I need a negative 1. Negative 1 times 3x will give me the negative 3x that I need to match this. And a positive 1. When I subtract it, I have a very satisfying answer. I get a remainder of 0. So I can say that the factors of this polynomial are 3x minus 1 times x to the 4th plus 4x minus 1. You can already see that knowing how to divide polynomials can be a big help in being able to factor, or in figuring out whether or not there is a factor. X to the 0 needs a placeholder too. We already saw this in the previous one. I think it was the very first one we did. So we've got a couple placeholders here because our powers are 5, 4, skipping 3, put in the placeholder, 2, 1, skipping 0, put in a placeholder. I'll go through this one quickly and we will be done for this session. Starting out looking rather familiar to us, isn't it? Looks familiar to me at this stage. Got 0, and then we bring down the 0, which isn't going to amount to anything, is it? And then this and this, which will be 12x squared minus 7x. How many times would this go in? 4x, so it's going to be right over here, and it's positive. 4x. This still looks familiar. I guess where it changes is right here. Let me look back. Yes, the only difference is this one had x to the 0 power. Our new one doesn't. All right, so we've got 12x squared minus 4x and we end up with a negative 3x. We could bring down the 0 plus 0. And let's see, we're going to do negative 1, just like we did before, but it's going to turn out a little differently because although I get the negative 3x I wanted, that added 1 is going to end up as a remainder of some sort. It'll be a remainder of negative 1. Remainder of negative 1. So my answer here is x to the 4th plus 4x minus 1 minus 1 over 3x minus 1, the divisor. Done for another one. This was a little longer than the previous ones. We've got 34 minutes and running.